Hello there. Let's create the first cryptocurrency object in the project, the wallet. The wallet is a crucial structure. It's going to serve three main purposes. First, it gives the user a public address in the system, and this is used to track how much balance the user has with the wallet. So this brings us to the second main purpose of the wallet, which is to track and calculate the balance of the user by examining the blockchain history. The third and final purpose of the wallet is to conduct official and cryptographically secure transactions with other members of the system by generating signatures. To start, we're going to add a new wallet directory to the project. The new directory is going to be called wallet. In here, let's start with a new testing file of index.test.js. In here, let's start by requiring a wallet class, even though it doesn't exist yet. But we'll assume that, we'll create one at a local index file. Let's make the wallet constant. That is the result of requiring a local index file that we're going to create in the future. Now this allows us to describe some overall tests for the wallet class. We're going to start with a describe on the wallet class. So the first parameter is the description. And then we have a callback for the second parameter of the describe function. We're going to run a few tests on an instance of this wallet class. So let's define a local wallet variable that we can use on every subsequent test. And before each test now, let's set this wallet variable to a new and fresh wallet instance for each one of our tests in this file. Neat. Now we'll construct some tests. So our primary concern with the wallet is that it has a couple key properties. For one, the wallet should have a balance to track how much currency the wallet owner has. Secondly, the wallet is going to need to have a public key. Again, that public key is going to be the address of the wallet that others will use to send currency to that wallet owner. So first, let's have a test that checks whether or not the wallet has a balance. We'll say it has a balance, and notice that balance is a keyword, so we're using backticks to mark that within the string message itself. Cool. As for another test, we'll check that it has a public key. And then in this case, the public key is going to be a camel-cased field name. Nice. For both of these tests, we can construct a very similar expect statement. Our expect statement is going to look at the wallet and then just gives us a very handy function. We can use the toHaveProperty method to check whether or not the instance contains a property. So the first one, we're going to check whether the wallet has a balance. Cool. And we can do something very similar to check whether or not it has a public key. Now I noticed that I need to spell balance correctly. There's only one L. And this has a public key. So this is going to enforce that the balance and the public key are present properties on the wallet instance. Cool. That gets us far enough with tests to move on to some code. So as per test-driven development, the next step is to run the tests in the command line. So let's go ahead and kill the blockchain application if you have it running. We only need one instance of the command line open. And let's fire npm run test. Now it goes through all the tests, and finally it gets to the wallet and it starts failing. All right, cool. So the first thing that we need to do is we need to add this wallet class. So let's make a local index.js file within the wallet directory. And what we're going to do is we're going to create a class called wallet and then export that. So here we have our wallet class, and let's add a line of module.exports equals wallet. And with that, we have different test errors now. Now it's checking that this object contains some nested properties, balance and public key. However, we don't have those fields yet. Now, how are we going to find the starting balance for the overall wallet? After all, we need to define the balance to get that first test to pass. Now, this is a pretty crucial aspect. We can either start everyone at a balance of 0, or we can give everyone a little currency to begin with. With this option, we can get the economy going with some starter money for everyone overall. Otherwise, if no one has any funds, how could anyone really pay for anything? So let's go with the starting balance option. We're going to go to the config.js file since we're defining a global value. And let's create a global value called starting balance. make sure this is screen cased, and let's give everyone 1,000 currency. We're going to be a pretty generous application. So overall, we need to include starting balance in the exported object in the last line of the config.js file. Cool. This allows us to go to the index.js file of the wallet, and let's grab that starting balance with the first line of the file. So we'll destructure it from the result of requiring the config file that is located at the root of the directory or the root of the project that is one directory back. Nice. And this allows us now to create a constructor for the wallet. Let's add the constructor here. We're going to set the balance property to get past the first test. And this will be set to the starting balance that we have now required at the top of the file. Cool. And saving that gets past the first test. So notice that the expected or the actual object has a balance of 1,000, but the expected nested property of public key is not present yet. Now, the question is though, how are we going to format this public key and set it? That part is still a little mysterious. How is the public key going to also act as the address is another question. So considering that it needs to be a unique address, perhaps a randomly generated ID could work. Now, that's possible, but this public key is not named address for a reason. We're naming the field public key because this field needs to be based on a cryptographic private public key pair. The reason we need this cryptographic key pair is that wallets will have to be able to conduct transactions with official signatures. By using the key pair, the wallet can generate a signature based off the inner private key. And then other nodes will be able to confirm if those signatures are valid by checking the proposed signature along with the proposed public key. These concepts are better understood in code. So without further ado, let's move on to incorporating the key pair and public key address within this wallet so we can get past this test and more importantly, have this cryptographic system within our cryptocurrency.